A Polish mathematician by the name Stefan Banach once said, "Mathematics is the most beautiful and most powerful creation of the human spirit." However, someone else said, "Beauty is in the eye of the beholder," meaning beauty exists purely in the mind which observes it. That is exactly why you won't see the beauty of mathematics if you don't love it. Today, Ms. K introduces you to a topic in mathematics called vectors. Vectors are somehow everywhere. The direction and speed of a car during a collision is a good example. The direction and distance from your house to your school or office is another example. Stay tuned to understand vectors a lot better. Welcome back to Maths Pro.
Today, we are going to talk about vectors. Now, a vector consists both magnitude and direction. When we're talking about magnitude, we're basically just referring to length. So in simple terms, when we are looking at vectors, we are looking at a quantity that consists both length and direction. Now, a vector can be denoted by perhaps A, B letters. A, B, like it could be any letter, example A, B, and then an arrow on top of that. Or it could be a small, maybe letter A or small letter B or whatever the letter. Or it could be small letter again, but then we put a line below that. So now we'll look at first a column, what we call a column vector. Now, when we talk about a column vector, we are talking about something that looks like this. A number on top, a sign as well there, say 4 there at the bottom. Now, how do we relate this to the definition that we just gave of vector? Remember, we said a vector consists of direction as well as length. So if what you are going to look at here is, this is what we are referring to as our length. And this is like -2, and this is +4. This is positive, we're just putting it there, but normally we don't put it there, but we know when there's nothing, it means it's positive. So when we have this, these signs are giving you, or these signs are showing you the direction of this vector. These numbers are showing you the length, the movement that was made. This top number, the top number, tells you the horizontal movement. So we have our horizontal movement, whether you went to the right or you went to the left. So that movement is denoted by the number on top, always denoted by the number on top. If you went to the left, meaning you came from your right going to the left, you always have a negative. And if you went from your left to your right, meaning that direction, you always have a positive. So remember, our top number denotes the horizontal movement. So this is your horizontal movement that was made. That horizontal movement is always denoted or represented by the top number. The bottom number in your length represents the up and down movement or the vertical movement. And if you go up, you are going to be having a positive value. If you went down, you are going to say you have a negative value. So to summarize that, we said these numbers are representing the length, the movement that was made. If it's to the left or to the right, we would say that is a horizontal movement. If we went to the left, we are going to make it negative. If we went to the right, we are going to have a positive value. And then we have a bottom number which represents the vertical movement. And that vertical movement will be, if we went up, we will have a positive value, and if we went down, we would have a negative value. Now, this is what we call our column vector. We're going to use this grid to answer these questions, for just to look at a few examples. In number 1, they're saying, write down the following vectors as column vectors. So we want to write as a column vector where we have a number on top, a number at the bottom, and we must have our sign to represent our direction. Now, The first one is AB. So we want to go to our drawing there and look for the vector that involves or that includes AB. So now we are going to take from this vector, we are going to have to represent it as a column vector here. We go to AB, so this already tells us that we are coming from A going to B. This arrow also just corresponds with the statement, because we have an A and a B and an arrow pointing to where you are going from, to where you are coming from and where you're going. Then if we look at this vector here, that is AB. So that is what we want to now give. How do we now get a column vector from this? What you do is you want to see when I came from A going to B, how did the movement that I made horizontally or vertically, and not all but end vertically. Now we can start with whichever way. The easier way to do this would be to connect this and make it a right angle triangle. Meaning I'm gonna make it not straight line, just so that it can be clear for you. So I'm gonna do this. So this is what I mean by having a right angle triangle. That's a right angle triangle. If you just look at that, that's a right angle triangle. So why did we do that? We want to see what was the movement, and we count the blocks. Now it depends if if there were x's here, your y-axis and x-axis, and they were labeled, we would want to understand the scaling between the points on your axis. But because there's no such a thing, we are just gonna count the blocks that were moved. So you come from A. Remember, you're coming from A going to B. It's very important because I can also ask you for BA, meaning you must then come from B. So if you look at that, you went 2 blocks to the right, meaning you have a +2. So that's your horizontal movement. That means you have your bracket, you have a +2 because that's your horizontal movement, and then you went up. So you went up and you went, remember, you are not counting the lines, because if you count the line, you'll be wrong, because you might end up counting from here, then you get a wrong number. So don't count the lines, count the blocks. So we are counting the blocks, so we have 1, 2, 3, 4. So you went 4 blocks up, meaning I have +4, and it's because I went up, it's positive. So that's our column vector. What do we have there? The direction is represented by positive, which we don't write there when it's positive, and then the numbers are telling us the length that was made. Then we go to CD. CD is this vector here. Now we want to see, we are coming from this point going there. The arrow is also showing us how we are going. Now they're saying CD, I can also do it the same way. It does not quite matter which triangle I see first. I could go like this and then like that, meaning I could do that. Then I have a right angle triangle there, or I could have gone like this. It's not a problem, as long as I know the horizontal movement that is made will be my top number, and the vertical movement that was made will be my bottom number, as long as I keep that in mind. Now let's say we look at that triangle now that we drew there. You are coming from C going to D. So if you go from C, this person moved 2 blocks to the right, so that is still +2. Remember, that's left and right movement, so that is horizontal. So if it's horizontal, it's your top number. Then this person came down 2 blocks, so you put a -2 because you came down. Remember, we said if you go down, it's going to be negative for the vertical movement. So here we have a -2, and we close it. Please don't go make it like putting a line there, because then I could say you are making it a fraction, so it will be -1 if you have to simplify that fraction. But a vector should always have 2 numbers. So please do not put that line there to make it a fraction. Then we go to MN. Just to make it visible, MN is here. M is here, N is there. So that is the vector MN. Then I check, okay, I can't actually create a right angle triangle there because I didn't make any movement up or down. So I can see that there's no movement that was made, vertical movement. So if there's no vertical movement, that means I can already conclude that my bottom number will be nothing. And I should, when it's nothing, when there's no movement that was made, I should represent that with a 0. I can't just leave it blank, because then it means I have not shown the vertical movement that was made. And remember, a vector should have both magnitude or length and direction. So if I don't put the length that was made, show it by saying it's zero movement that was made, I would be wrong. Then I am not done, so I'm going to say, remember, that's just the vertical movement, but there was a right, like from M going to N, I moved to the right and I moved 3 blocks there. So I'm going to say it's going to be 3, 0. That's going to be my column vector MN. Then we go to NM. NM is, you can see that there's no NM there, but there is MN. So if there's MN, I can get NM from that same vector. I just look at it like I'm going to change my arrow, and I'm going to change it to this side, because this time I'm coming from N going to M. So if I come now from M, I'm basically doing here is I'm going to the left. So I made a negative movement. So I moved to the left. So I'm going to have a -3 because I moved to the left, and there's still 0 movement there. Now, I gave this example because there are some people who think just because MN is 3, 0, they think that NM will be 0, 3. You never swap those numbers. You only change the direction. If I change the letters, meaning I'm coming from the last point going to the first point, then it tells you, I can actually say, I am just going in the opposite direction, but I'm making the same movement that I made. So all I'm going to change is the sign. If MN was +3, 0, then NM will be -3, 0. 0 is, I can't say -0. 0 is nothing, so it's still no movement that was made when I came from N to M. Then in number 2, they are saying, draw the vector KL, which is -2, -1, on the grid above. So we are drawing that vector anywhere on that grid. So it's up to you where you want to start, because we are not limited by some coordinates here. So what you are going then to do is, okay, you go to a certain point, we call it K. Then you are going to move 2 blocks to the left. So I'm going to move 2 blocks to the left, and then I go 1 block down. So I went 1 block down, and then I label that point L. So what did I do? I went 2 blocks to the left, 1 block down. Why did I go to the left? Because the direction is negative, and to a negative direction, for the top number I go to the left, and for the bottom number I go down. So I did that. Then I just connect these 2 points. I must be straight. I just connect those. Then I put this arrow in there. Why do I put that arrow? Just to show that I'm coming from K to L, not L to K. Okay. Then we have addition of vectors. Now, see triangle ABC. Now we have a formula that says if I want to get vector AB, I can get it by saying vector AC plus vector CB. What does that formula, to make that formula, or for me to remember this formula, what this is basically saying is that I want to find the vector AB, meaning I want to come from point A to go to point B. I can always go from point A to C first, and then I come from C to B. So I'm still coming from A to B, but I went to pass by somewhere else, then I go to B. So the theory here is I could, as long as I'm coming from the same point, I could go in whatever direction and come back. As long as I'm going to the next point, I'm going to get the same thing as when I just take the straightaway shortcut. Okay, now this is the formula, so it just means I can actually play around with this formula. If I want AC, I could go from A to B first and then add BC. If I want CB, I could go from C to A first and add AB. Okay, for example, if vector AC is little a and vector CB is -b. Now, and what are they saying here? They want you to find the vector, like they wouldn't give you this formula. The question would just come, they will maybe give you a drawing there, and they will just say, find the vector AB. They will label it, or they will tell you what the other vectors are. And they will say, find the vector AB in terms of A and B. You can see there's A and B there. As long as I'm coming from the same point, I can always go to another point first and add going to the point that I want to go to. So it means the first thing I will write down is this formula. Because we have it above there, we're already just going to use it. It actually means vector AB will be equal to AC, which is little a, plus CB, which is negative B, which is going to be A minus B, to simplify it, because we don't want to leave this with two signs. We want to simplify it. We just applied this theory that we learned, that if we come from one point to another point, we can, as long as we are coming from the same point, we can always go to C first and then add coming from C to B, then we still get the same answer as this vector. Now, so we have A minus B. We have to simplify this and remove this plus and negative, because we don't want to have two signs, and we know that the plus times a negative, the negative is what we get, so we have a minus there. Now, that's just the first. Now, to understand this theory better, we want to find, let's say we are using the same example and same things that we know, but we want to find, let's say we didn't know that CB is negative B. We want now to find it. Let's see if we are able to get that answer. So we know that if we are coming from C to B, we could go from C to A first, and then from A to B. So what do we know? We know that if we are coming from a certain point going to another point, we can always go to another point first and then add, going now to the destination that we want to go to. Now, so we have that in the formula. What did I say? CB is the same or is equal to CA plus AB. Now we know AB is A minus B. We know now that AB is A minus B. So we are going to come and replace that. So we know CA, because it's in the opposite direction. This was positive A. Because it's in the opposite direction. So we want to come back from now C going to A. We have a negative A because it's opposite direction. So we have negative A plus AB. We just know now that it's A minus B. So we now want to come and say, okay, we simplify this. This is like negative 1A plus 1A. And negative 1A plus 1A is the same as 1A minus 1A, which means it's gone. If you are not sure, you simply take your calculator and just press negative 1 plus 1. You get a 0. So it means A is gone. I am left with negative B. That tells you the theory works whichever way you come around. As long as you know, if I want to go from one point to another, that vector, I get the same vector as when I go from the same original point to another point and then go to where I am supposed to go to. Okay? And then we have subtraction of vectors. With subtraction of vectors, it's basically just we have a vector and we have to subtract another vector. But this could have also been a plus, so what we would apply then, what we would do then. We don't quite have a theory like the one we have for additional vectors. Here we're just going to subtract the vectors. We have a column vectors and we need to subtract them. So we have some examples here. A question could be like simplify, and then we have, for example, here in A, negative 2, we have a vector 3, 2, minus, and then we have a vector negative 4 and negative 1. Then, or in B, we have that if vector M is 1, 3, and vector N is 2, negative 2, find 2M minus N. So, we're going to start with A here. So what you want to do is you multiply out, because this also comes or brings in the multiplication of a vector with a scalar. So if I want to multiply a vector, which means I want to multiply a vector with a single number outside, I can do it this way. I'm just going to multiply that number with each number in my vector. So what I'm going to write every step down. So I'm going to write negative 2 times 3, that's my top number, and then at the bottom I will have a negative 2 times 2. This is just to accommodate my calculation so that I don't leave out any sign and all that. And then I have minus, this is still negative 4, negative 1. I'm writing this out in every detail so that you see where. Remember, simplifying means I want to write this as a simple thing, meaning until a point where I cannot do anything more. So I don't want to leave a minus there because I can minus, but I want to have one single vector. So I'm going to say negative 2 times 3 is negative 6, negative 2 times 2 is negative 4. So that's my answer to that. Then I have minus, I'm just writing every step down here. Then now I want to bring these things together, but it's very important that I don't get to just press on my calculator, because I could forget something. But if I'm writing everything out, I'll be able to see the mistakes that I did in my calculation and figure out that, oh, I shouldn't have, or I forgot the minus here. So I'm going to write everything down. Remember, I'm going to have one vector, so I'm going to have the top minus the top and the bottom minus the bottom. So I want to accommodate that, so I'm going to make it so big, like I just want to accommodate my calculation. So I'm going to say this is -6 minus -4. All I did was copy these down, and then I go to -4 minus -1. All I did was, because they are sharing that operation in the middle, and then I did that. Then I closed that. So that's what I actually have. But I can't leave it like that. It doesn't even look so nice. So I want to have it as a single number. Remember, I only want to have one sign there at the top number and one sign at the bottom number to denote or to represent the direction. And then I have my numbers to represent the movement or the length. So this is going to be, this is just equal to -6 plus 4. And then I have -4 plus 1. That's what I actually have. Now, what is -6 plus 4? That's like saying 4 minus 6, which gives me a -2. Then I have -4 plus 1. Remember, it's like saying 1 minus 4. And we have 3, because remember, basic working with directed numbers, when I have different signs, I subtract the numbers, meaning I'm going to say 4 minus 1, keep the sign in front of the bigger number, which is negative. That's why I have a -3. You could still also use your calculator there. You don't, you're in the exam, you don't, if you are writing your grade 12 exam, you are not really there to prove your mathematics when you know that you have been maybe having problems or trouble with science. So you want to make sure. So now in B, they gave us this vector M and vector N, and they want us to find 2M minus N. Now what I'm going to do is, so this is what I'm trying to solve. I am told that M is that and N is that. So the first thing I want to do is I want to replace the M and the N, because I know them as the column vector. So I'm going to do that. 2M is -1, 3. So I'm going to put the M there, minus N, which is 2, -2. So what did I do? I just substituted my variables with the column vectors that I know, that I'm told they are equal to. So I did that. So remember, now we don't quite have to write every step down. Now we should be able to remove the numbers that we have outside. So we have 2 times -1 is -2. 2 times 3 is 6. So we have that first vector. So here we have -2, -2. I just wrote it down there because I have nothing to do there yet. Now, I could also apply already the negative there, then change that negative to plus, but that can confuse some people. So I don't want to get there. I just want to have everything the way I have it so that I don't get confused. Then I go to the next step. I just have my top numbers with the operation between them and my bottom numbers with the operation between them. Why do I put the negative in brackets? Just because I don't want to get confused. I want to know that this is just what came from that bottom of that vector. Then I have that, okay, this is actually -2 minus 2. Remember, same sign, add the numbers, keep the sign. Or you can simply use your calculator. -2 minus 2 is -4. And 6 minus -2 is like 6 plus 2, because this negative cancels. So I'm going to have 8, and then I am done. Because what were you doing? You're basically doing the same thing, except that here we needed to first substitute so that we can get something that looks like that. Then we just apply the same methodology that we did there. Okay, so we are going to look at some more examples here, and then how we can answer the questions. Now they're saying DEFG is a parallelogram with M a midpoint of GF, M. So DE is P. So you look at EF is Q, and find in terms of P and or Q these vectors. So what we want to do is, because we were told it's a parallelogram, we want to label everything that we know. We know that EF is equal to, in a parallelogram, we know that EF is equal to DG. So if it's in the same direction, it will be the same vector. As well as GF will also be, this whole vector will also be P. Because if it's in the same direction as DE, but the fact that it's a parallelogram makes the two sides equal, and that therefore the vector is also the same. So we know that this whole vector is P. Now we want to answer the question. So we have EG. Now where is EG? EG is here. So you are allowed to draw your own line and just to connect the 2 points where you are coming from to where you are going, to create a vector, to have a better understanding of what is going on. So if I look at now, after labeling all my sides because of the properties that I already know of, I am going to now be able to find this. What does this look like? It looks like I have a triangle EDG, and I know that I want to find EG. So I know that vector EG is actually going to be equal to EG is going to be ED plus DG. How did I come to that? The theory that we just learned, we're looking at this as this triangle. Then we could also look at it at that triangle. It should come to the same answer. Now we came up with a formula to just make things easier for us. So we have EG. I could go from E to D first, and then D to G. As long as I'm coming from the same point, going to the same point, I could go another way and get the same answer. So I got that. That's my formula. Now I just want to label or replace my vectors with either P or Q to just have an answer, because I need to give it in terms of P and Q. So EG is ED. What is ED going to be? Because it's in the opposite direction, it will be negative P. So I'm going to have negative P plus DG. DG is still in the same direction as the original vector. DG, still DG. So I'm going to say it's still just plus Q. So I'm going to have that EG is actually negative P plus Q. Or if you maybe looked at it another way, you could say it's Q plus negative P, which means Q minus P. Or if you look at it another way, you would have Q minus P. And those two things are the same, as long as the sign in front of P is negative in both and the sign in front of Q is positive in both. It's the same thing that we are talking about here. Okay. Now, I'll pause that video and then you try to find vector GM. Then you come back and continue. So now we try to find vector GM. So, okay, GM is actually just coming from G going to M. So I'm going to half of GF. So I know GM is half of GF. And what is GF? GF is P. So it means this is half P. So that means your GM is half P. Or you could say P divided by 2. Those two things are the same. When you multiply something with half and divide, it's the same thing as when you divide something by 2. Okay? So that's how you find GM. This vector from there to there is half P. Now, I might need to use that, so I need to have it down there, because they're asking about DM. Where is DM? DM is here. I am allowed to connect the points I want to connect, to just have a clear picture of what vector I want. So I have my vector there, so I can also take my pencil and draw this information out to have it easier to and not so complicated. And then I'll be able to remember from class. When I see a triangle and I remember vector from one point to the other, I could go another way and still get the same answer. So I have D, M, G. What is this again? This was Q, so this is Q. And what is this? This is half P. So from there, I can see that, okay, DM is actually DG plus GM plus GM. So what is DG? It's Q. And what is GM? It's half P. Then I'm done. If I see that I get a question and I see that in my final answer I have P and Q and I have another P again, another Q. I need to make sure I simplify them and group the like terms.
Thank you for watching. Please don't forget to subscribe, like, and leave a comment. See you in the next video.